Hey, how you guys doing? Today we're going to do a reverse integer algorithm. Here's the Java version. So this algorithm I think is pretty simple as the names already pretty much explained it. So basically if you have like a 1, 2, 3, we want to return a 3, 2, 1. If you have a 1 minus a 1, 2, 3, we want to return minus a 3, 2, 1. But there's other cases that might be making this algorithm interesting. So if you have a 10 and 100, what would be returning? Normally, I think it will, like whenever you do it in the code, I think it will return a 1. It will always try and return a 1. So I guess you have to add some extra steps to actually keep tracking the zeros. So you can add up the 0 to in front of the 1, but I think the program will automatically subtract all the zeros. But definitely I think there's a way to achieve this, but we're not going to focus too much on this since we only want to talk about this algorithm in general. Then also there's another case is if you have like an integer such as this size, and you are on a operating system that's a 32 bits or something, where the integer can only hold 32 bits, you're going to have overflows, which we don't want that happen. It will crash the program. So since we're on the Mac OS, there's interesting thing about Swift is Swift will actually choose the integer bit size based on the operating systems. So if you have a operating system that's a 32 bits, the maximum holding integer size for Swift is a 32. If you have a 64, it will be 64. So, but I think it will be different on the C++, in C++ language and also Java, but I'm not quite sure. I'm pretty sure people out there, you guys probably more familiar with in Java or some different languages. But for this purpose, for this algorithm, let's just get started. So here I already kind of like created the algorithm already, and I copied over this instruction, so you guys can take a look later on. I'll definitely post on my GitHub and also in my website that's kind of like articles talk about the algorithm stuff. So you guys can go there and check out. And here's the function. Here's the algorithm that we take one integer input that we want to return the return value integer. So first we create a variable here that will assign this input to the x, so we can constantly update the x. Then we created this return value variable that the initial value is 0. So then we need to use a loop because we want to keep subtract the value of the input integer, which will be the x here. So then we can check if the value is end up to 0. If it's 0, then we need to leave the loop. So if we have a 1, 2, 3, we come in as 10 times return value, which first time it will be 0. So here the two values together will be 0, plus x remaining 10 versus 123 remaining 10 is actually 3. So 3 plus 0 is actually 3. So the return value will be updated to 3. Then now we have to update the x. So later on when we come to top to check if it's equal to 0, then we can actually to do that, because otherwise it will be always 123. So 123 divided by 10, normally it's supposed to be like 100, it will be 12.3, but since we're here is using the integer, so the system with the Swift will automatically take the integer value of the whatever this x divided by 10 is. So which is 12 in this case. So then we update the x from 123 to 12. So then we come back again and again until we hit it to 0. Then the return value will actually equal to 321. So after that, we can go down here to check if the integer is overflow or is below the minimum holding value of the integer. I'm not quite sure if I'm using the right function here, but I think you can try it, or I can try it for you guys. I think there's probably a different function for it. Might need to be tested, but you definitely want to check the overflow cases, because otherwise will be something your program or your application will crash for sure. So I can actually try that for you guys, but here is the example. 123, then we return a 321, minus 123, then we return a minus 321. Then 1003, return a 3001. Since my operating system is a 64 bits, so my maximum integer can hold actually a 64 bits. So let's try that if we overflow, if this function actually correct. I'm pretty sure it's correct, but maybe not. I'm not completely confident. So let's add like 8 zeros into this integer. 2, 3, 4, 5, 6, 7, 8. All right, so you haven't overflowed yet. Okay, one more. Okay, one more. Okay, yeah. So I guess this function actually doesn't work. Well, maybe it does. I think it does. Yeah. It just here, right here at this point here. I don't think. Okay, the integer literal 1003 overflows when stored into int. Yeah. So you cannot store this into the int. But whatever the value you calculate out, I think you might be able to check with the int max and int min. There's two functions here. That's two built-in functions actually. Yeah, so here you go. Here's the reverse integer algorithm. Hopefully, it can help you guys a little bit in the future. But you definitely feel free to comment and give me some suggestion or about like how can we improve this algorithm better to handle the 10 and 100 case, like whenever you reverse, and also the overflow cases. How can we sign stuff like overflow cases if there's a better way to do it instead using int.max, int.min. So thank you guys very much, and please subscribe and like my videos, and I'll definitely post more videos in the future. And just checking every week or turn on the bell notification. Don't miss any of the videos, and I'll see you guys next time.